Hi guys, and welcome to this other video. So today in this video we are going to talk about FortiGate HA, so high availability. So during this video we are going to talk about we'll see what is FortiGate HA, how it works, HA operating mode. We'll also describe we'll see the election process, and we'll see a step-by-step deployment on how to put in place FortiGate HA on a network infra. Then we'll do some practicals as usual. So this is our practical environment that we are going to implement at the end of this video. So we are going to have this topology where we have two FortiGate devices, and where we are going to configure high availability between these two FortiGate devices, and we'll see how to manage traffic from these devices to the internet, and we'll see how to do some failover to see how it works. So this is going to be the diagram that we are going to use on our GNS3 environment. So in this environment, these are the activities that we are going to do. So you have task 1, configure HA; task 2, simulate the failover; task 3, manage IP; task 4, switch HP high availability mode. Then task 5, we'll see how to enable override. Task 6, we'll see how to add a third FortiGate firewall on the HA cluster. So we'll explain all these details when we are in the practical step. So before we jump to the practical, let's take a few minutes to explain some key concept of FortiGate high availability. So what is FortiGate HA? So FortiGate HA is the process that led you to put together two or multiple FortiGate devices so that the cluster can provide redundancy. So like if you are on an infrastructure where you have multiple users who need to access, let's say they want to access internet, and you want to make sure that they always have internet access, or they always have a path to access internet, even if a firewall is down. You can implement a firewall policy by putting together multiple FortiGate devices, as you can see on this image. So FortiGate uses its own protocol called FortiGate clustering protocol to discover new members that you can add to a FortiGate HA cluster. It uses the same protocol to elect the primary FortiGate, synchronize data among all the members, and monitor the health of each member participating in the HA cluster. So how does the HA works? So FortiGate high availability operates in, we say, two modes. There is active passive mode, and there is active mode. So in the active passive mode, it means this in this mode, for example, if we take the case of this image, on this image you will see that we have like two firewall that are actually positioned at the top to get access to the internet. It means a user in the accounting network, if he want to access internet, he can either go to the internet, either passing through this FortiGate, or on this switch, his traffic can be routed to these other FortiGate devices so that he can access internet. Same for the users in the marketing network. So when the firewalls are working in active passive mode, it means in this mode, one FortiGate is actually managing all the traffic, and the other one is in a standby mode. In case the primary FortiGate has an issue, then the one that is in standby will take over. And in the active mode, both are sharing the traffic. So maybe one will be managing maybe 60% of the traffic, while the other one is managing 40%. So depending on your infra and what you want, the type of traffic that goes on your network, you might decide to go either you are using your FortiGate devices in active passive mode or in active mode. Pay attention that you can add multiple, not only two FortiGate devices, you can add multiple FortiGate devices together in your high availability cluster to make it more redundant. So what are the prerequisites if ever you want to implement the FortiGate high availability? So there are two particular category of prerequisites. There's one category related to hardware and software, and the other one is network configuration. So under hardware and software, you need to make sure that the FortiGate devices that are taking part in the cluster, on the HA cluster, have the same model. So if you are using a FortiGate 60F or any other model, you need to make sure you have the same model for all the FortiGate that are taking part to the HA cluster. The same hardware configuration. It means the same number of interfaces, same number of hard disks or hard disk module, editing. So physically, they need to have the same hardware configuration. Also, same level of firmware. So if the primary FortiGate, or if one of the FortiGate is running maybe FortiOS version 7.4.9, you need to make sure the other FortiGate devices that are going to join the cluster also are running the 7.4.8 version of the FortiGate or FortiOS. So as we said, identical licenses is required. Let's say, for example, you have two, let's say you are doing a HA cluster with two devices. If one of the devices have, let's say one of the devices have license for VPN connection and the other one does not have license for the VPN connection, when you put the two devices together in a cluster, in that case, your cluster will not be able to run VPN will not have access to VPN features because one of your FortiGate devices don't have the VPN feature. So your cluster will run with the least license features. So the licenses that the features that are available for the devices, the device that have least feature. So you also need to make sure the firewall are running the same operating mode. As you know, your FortiGate device can run either in the transparent or in the NAT mode. So if you want to make them participate in the HA cluster, you need to make sure they are all running in the same operating mode. So talking about networking configuration parts, you need to make sure on the FortiGate devices, you need to specify what are the dedicated heartbeat links. So the heartbeat links here are going to be like the interfaces that you will use to communicate between the different FortiGate devices. Let's say you have two FortiGate devices. So the heartbeat links here are going to be the links that will be used, the links that each of them will use to get to know whether the other one is still alive or the other one is actually out of network. So that's dedicated. You need to have dedicated heartbeat links. So dedicated heartbeat is required for heartbeat and data traffic between members, as we said. So you also have to do to get matching interface configuration. As we said, ideally you need to have FortiGate devices that have the same model and the same physical hardware configuration. So if you are running, let's say your FortiGate need to have maybe 10 interfaces, 10 Ethernet interfaces. So you need to make sure that if you are configuring static IP addresses on some interfaces on FortiGate 1, you need to do the same on FortiGate 2. So on the two FortiGate devices, if in case you are running it on you are running a two device high availability cluster, you need to make sure that the HA group ID and password are identical on both devices. So this is configured on each device. You need to make sure you have the same HA ID and password on the same on the on the devices that are taking part on the HA cluster. So talking about the interfaces, so what you need to know, for example, in this image we have a HA cluster for two devices. So you notice on these two devices we have like these two links which are in green color. So talking about interfaces on FortiGate HA cluster, you need to know we have two types of interfaces. You have what we call monitored interfaces and we have what we call heartbeat interfaces. So monitored interfaces are interfaces that are connected to other resources which are not part of the HA cluster. So monitored interfaces are the interfaces that are connected to other devices that are not part of the HA cluster. Then the heartbeat interfaces are the interfaces that are connected, we say the link that connects the devices that are part of the cluster. So that's easy to understand like this. So all you need to know is that so heartbeat, as we explained previously, heartbeat is used to check continuous communication between the cluster nodes to make sure each one will use the link to detect if the other one is still alive, like that. So best practices recommend that you should have at least two heartbeat links on your clustering when doing your clustering. So if you have like two devices in your cluster, make sure you have also two links to detect if each of them is alive. Then the monitored interfaces are the interfaces that are connected to other devices that are not part of the. So the monitored interface are the interfaces that are usually used to trigger the failover. So these interfaces are the one that will be used to trigger a failover if there is a network that goes down. So as we said, we can configure our FortiGate HA so that it works in either active passive mode or in active mode. So if, for example, we want to run it in active passive mode, it means we need to elect one of the FortiGate devices to run like the primary FortiGate, and the other one will be the secondary devices running as a standby, being in standby mode. So the primary FortiGate election process is like this. So on the FortiGate, there is what is called override. Override is like a configuration that when you do on your FortiGate, you will change. It lets you to change the order on in which the election process will go. So the FortiGate feature override feature is a setting that you can configure on your FortiGate device so that it will change the order in which the primary FortiGate election process will be processed. So let's see. By default on your FortiGate device, the override configuration is disabled. So this is the default config. By default on all FortiGate devices, the override config is disabled. So in that case, if you maintain it like that, so if you take your FortiGate devices and you do not change the override value, so you left it by default to disable. So this is the process. So the primary FortiGate election process goes like this. So FortiGate HA begins by checking the connected monitored ports. So if the FortiGate process will begin by the connected monitored ports. So to determine which is going to be the primary FortiGate, the FortiGate that have a higher number of connected monitored port will be chosen as the primary FortiGate. So as we said, the monitored port, for example, for this image, for each of these FortiGate devices here, each of them have two monitored ports. So port 1 and port 2 are connected to the monitored port. So if one of them is having more monitored port than the other one, then that FortiGate device becomes the primary FortiGate. In case they have the same number of connected monitored ports, now we will go on what is called HA uptime. So the HA uptime is for how long each device has been up. So let's say, for example, this one of the FortiGate was power on. Let's say power on 10 minutes before the other one. So in that case, if there is a tie on monitored interfaces, the next decision maker will be the FortiGate that have the longer high availability uptime will become the primary FortiGate. But there is an exception to this. So this only works if the difference in the HA uptime is less than 300 seconds. So 300 seconds is 5 minutes. So if the difference between uptime on the two FortiGate devices is less than 5 minutes, then this criteria will not be used. We will then go on the next criteria. This is only used if the difference between the HA time between the two FortiGate devices is greater than 300 seconds. So let's say in the case where there's a tiebreaker and this one is not going to be used. So the next criteria here is going to be the priority. So by default on all FortiGate devices, each FortiGate device have a default priority of 128. So if connected monitor port is not used, will not be used to elect. If HA was not able to be used to elect, we'll go now on priority. So priority here gives you the possibility to modify, because by default it is 128 for each FortiGate. It means if you go on one of the FortiGate devices and configure and change this value, maybe let's say 129, it means the FortiGate now will have a higher priority, and in that case that FortiGate device will become the primary. In case there is a tiebreaker still on the priority, now we'll go on the last criteria, which is serial number. So at least here, all we know is that, at least at this point, we know serial number are unique for each FortiGate device, right? So here, if there is a tiebreaker on the three previous criteria, at least on this last one, we will be able to select, or we'll be able to choose one of the FortiGate devices to be the primary FortiGate. So this is the primary FortiGate election process when you have override disabled. So we start with connected monitored interfaces, HA uptime, priority, then serial number. So we also have the other option where you have override enabled. So as we said, override is the value, is a configuration that you can do on your FortiGate device on command line. So you go on your FortiGate device on command line, then you enable override. When you enable override, it will let the cluster HA election process to prioritize priority over HA uptime. So remember in the previous slide here, the default when override is disabled, HA uptime comes before priority. But if you decide to enable override, in this case, priority will come before HA uptime. So in this case, it means you can easily decide which of the FortiGate devices is going to be the primary, because if at this step you can modify the value of the priority of each of a FortiGate device, then at this second step, you can easily decide, or you can make sure that this a particular device is selected as the primary FortiGate in your HA cluster. So that is basically the difference between the two election process. All depend on the override configuration, if you configure it or not on your FortiGate device. So talking about failover protection type, so these are the different elements that can trigger FortiGate high availability, or let's say failover. So the first one, for example, we say the first one will be FortiGate device failover. If one of the FortiGate devices have power loss or hardware issue, automatically there will be a failover to a secondary FortiGate. If there is a link failover, let's say monitored link failover, maybe one of the link is down, automatically a failover will be triggered and traffic will be forwarded to the secondary FortiGate device. There's also what we call remote link failover. So remote link here, which is different to what we call link, is simply that you can connect your FortiGate device to a device that is connected to an external network, which is not like your internal network. Like just connecting it to an external network, making it to consider that interface as a monitored interface. So in case that the link to the remote network is down, this will also trigger failover, so that the secondary FortiGate device will take control of the traffic. Also memory-based failover. So if memory utilization on the primary FortiGate exceeds a configured threshold or some monitored period that you can configure on FortiGate, automatically there will be failover to the secondary FortiGate firewall. Also with SSD failover, there's SSD failover. So FortiGate or your FortiCloud can detect, your FortiOS will detect errors in file system on your SSD drives. So if it detects, then automatically a failover is immediately triggered to the secondary FortiGate device. There's also what we call session failover. So there are some stateful firewall sessions, mostly related to I think VPN or IPsec sessions, that are configured in such a way that if the primary FortiGate is overwhelmed with too much connection or sessions, a failover can be triggered, so that some part of those sessions or some traffic or the traffic for those sessions can be failover or sent to the secondary FortiGate device, so that traffic can continue without interrupting ongoing connections. Now we are going to jump on our lab environment. So on our lab environment is on GNS3, where you have these two FortiGate devices. So we are going to configure a high availability cluster between these two FortiGate devices. So we'll see how to set up the different interfaces, monitored and heartbeat. Then we'll see how to get these devices to access internet, either going through one of these FortiGate devices. So I've planned some activities that we can do here. So we are going to start with task 1, which is going to be configuring the high availability. So on each FortiGate device, we are going to configure them at we configure each FortiGate device in active passive mode. We'll see what is management interfaces. So we need to know that when you configure your FortiGate devices, the cluster that will come out of after combining the two devices, that cluster will get a new IP address from which you will now get access to the HA cluster. So the management interfaces for each FortiGate devices will need to be configured after on task 3. So we'll talk about this during the implementation. So task 2 will be on simulating failover. So here we'll try to simulate some failover situation, like disconnecting some monitored interfaces or changing priority or completely shutting down or deleting one of the FortiGate devices. Then we'll check to see in the command line to see the reason for the new election, because as we said, when you do simulate a failover, there will be a new election. So we also do we also jump on task 4, which is going to be switching the HA mode. As I said, we'll start by configuring the FortiGate devices in active passive mode. Then in task 4, we'll see how to switch now the HA mode from active passive to active. Then we'll also perform some checks to see how traffic works when we are in active mode. Then at task 5, we'll see how to enable override, as I explained in the previous slide. So override is that setting that when enabled on a FortiGate device or on FortiGate devices, the election process criteria order will change. Yeah, criteria order will change. So I explained in the previous slides. So we'll enable this on task 5. Then we'll see how to play with the priorities to see how the election process is going to change. Then at the task 6, we are going to add a third firewall on our cluster. So we'll see how to add a third firewall on our cluster so that we have a cluster that has 3 FortiGate devices. Then we'll do some failover to see how the election process will happen with 3 FortiGate devices. So guys, stay tuned. Let's meet in the next video to perform this activity.